please open to page 215 in your student journals. Today we're going to continue multiplying our polynomials, but we're going to look at a couple of special cases. If we take a look at example A, what I would like you to do is use whichever method you like, so distributing, box, or FOIL, and multiply those two binomials together. Whichever of the three methods you used, you should have gotten x squared minus 3x plus 3x minus 9 before you simplified. Then after you simplified, we combine our like terms, and we end up with x squared minus 9. So the two middle terms, we ended up with opposites. We had a negative 3x and a positive 3x, so they equaled 0. We were left with x squared minus 9. Take just a minute and multiply letter B using any of the three methods that you prefer. No matter which of the three methods you used, you should have come up with x squared plus 4x minus 4x minus 16. Now the order of the plus 4x and minus 4x, that doesn't matter. You need to have a plus 4x and a minus 4x. Combine our like terms, positive 4x and negative 4x, we combine those, we get 0. So we're left with x squared minus 16. Same thing for letter C. Go ahead and multiply those two binomials using whichever of the three methods you liked. No matter which method you used, you should have gotten 9x squared minus 3x plus 3x minus 1. And again, the negative 3x and positive 3x can be in either order. When I combine those like terms, I end up with a 0. So I'm left with 9x squared minus 1. On all three of these, after we combined our like terms, we ended up with a 0. Our like terms ended up being opposites, one positive, one negative of the same. We ended up with a 0 each time. So our end result for each of these, we ended up with a binomial, and each time we ended up with subtraction. So let's take a look at what could cause that. If we look at each example, each binomial, one was a plus, one was a minus. One was a plus, one was a minus. One was a plus, one was a minus in both cases. The other thing we need to notice is the terms inside were the same. We had an x and a 3, x and a 3. X and a 4, x and a 4. 3x and a 1, 3x and a 1. So if we have the same terms, but one is adding and one is subtracting, our end result will be a binomial and subtraction. Binomial, two terms, subtraction. Binomial, which means two terms, and subtraction. When we have a binomial like this with subtraction, and the two terms that make up the binomial are what we call perfect squares, these end results are known as a difference because of subtraction of two squares. Now you might be thinking, Miss Golly, what do you mean by the squares part, or perfect squares? Perfect squares are the result of squaring a number. So perfect squares would be things like 1 squared is 1, 2 squared, 2 times 2 is 4, 3 squared, 3 times 3 is 9, 4 squared would be 16, 5 squared would be 25, etc. And then for the variable piece, x squared is a perfect square, x to the 4th is a perfect square, x to the 6th is a perfect square, etc. So in other words, if you have an even exponent, you have a perfect square. The second special case I want to look at for our multiplying if we take a look at letter D, we have a binomial, but the whole binomial is being squared. What this means, it means that I have to take that binomial times itself. So it does not just mean I square the x and I square the 3. To square that binomial means I have to take that binomial times itself. Then from here, when I have x plus 3 times x plus 3, now you have to choose which of the 3 methods you like, distributing, box, or FOIL, to finish off the question. So no matter which method you use, you should come up with x squared plus 3x plus 3x plus 9. Combine our like terms, and we get our end result of a trinomial. Same thing we see in letter E. We have a binomial squared. It means that binomial times itself. Then again, from here, we have to use whichever one of the 3 methods you liked in 7-2 to finish off the question. So we should get an x squared minus 2x minus 2x plus 4. Combine those like terms, and we have a trinomial for our end result. Same thing in letter F. 3x plus 1 times 3x plus 1. Use any of the 3 methods you would like to finish that off, to do the multiplying. We'd get 9x squared plus 3x plus 3x plus 1. Combine your like terms. I might be thinking, Miss Golly, why is this a special case? It's a special case because I want to make sure we're aware of how to set it up. X plus 3 squared does not mean I just square the x and square the 3. It means x plus 3 times itself. The other reason it's special is if we look at those like terms we combined, they're the exact same. 3x and 3x. Negative 2x, negative 2x. 3x and 3x. That will happen every time you have a binomial squared and you do the multiplying. That will happen every time for you. The name for this one, the end result, and this is just something I want us to hear now, and we're going to use in our next unit. This is called a perfect square trinomial. So our end results, we had the term difference of 2 squares, we have the term perfect square trinomial. Those are just things that I want to mention now, and also that idea of perfect squares. Those are just things I want to mention now, so then when we need to use them next unit, they at least sound familiar to us. So don't panic about naming them right now. It's just something that I want us to at least see during this unit and hear for the first time. At this time, what I'd like you to do is go ahead and use any of these notes you'd like. Complete your progress check. When you're finished with the progress check, please check it and check it in with me.